All right, here we go. Okay, so I have the scoring guidelines here. I also have my answers. Um, so we will see what you think. I'm going to do some highlighting today. I'm hoping that will help us out. We're starting with number 1A. And this is confusing. So let's just make sure we have it. You have to have at least 3 of the components 1 through 4, and you have to have component 5. So and is a big and, like the and symbol. You have to have at least 3 of these, and you have to have component 5 to get an E on this problem. Direction, you need to say that it's positive or increasing. Strength, you needed to say strong. I learned my lesson last time, and I put strong. Yes.
Figure out why it's strong. When you see it, you can number over 20.
It gives you a R squared value of 0.819.
Yeah.
Okay, which I want to say is excellent investigation by Gabe. However, if you do not have the graph and you're just given R squared, you can't specifically say that it's strong because you don't know if it's linear or not. So just throwing that little tidbit out there. Don't be tricked by just giving you an R squared. A calculator will give you an R squared even if something is not linear. So just a note. But Gabe is correct because you had the graph to check. Okay. Form is linear or approximately linear. Unusual features, no points with large discrepancies from the pattern. So this is no outliers, basically. And then context, some kind of association between length and mass of bullfrogs. So notice they're really sticking on that context point. You got a P if you only had 1 or 2 of the components 1 through 4 and component 5, or if you had at least 3 of 1 through 4 but did not do context, and an I either way. Yes, honey. Relationship is fine. That's actually going to come up later also. So wherever they say the word relationship, you can substitute with association or back and forth. Okay. Here's mine. I said, okay, now you can tell me, you think that I might have gotten a P here. I said positive, and then I said, oh, none. The problem with this is I assume that the grader is going to know that when I said, oh, I meant outliers. Yeah. I just wrote the word none out of nowhere. So just a quick, like on that one, you might want to put no outliers instead of just the word none. You could put a possible outlier, linear, and then I put strong association between length and mass for bullfrogs. So this, by the way, can be written in sentence form. You could say a positive, linear, strong association between length and mass for bullfrogs with no outliers or something like that. Okay. Do you think I got a P because I didn't say what O was? I think I might have.
You got the other parts.
1, 2, I did. You're right. You're right. You're right. But if I would have put moderate, it would have been all over. Okay. But the last set of FRQs freaked me out. Okay. All right. So part B. 3 components have to be met for an E. Identifies the value of the slope as 6.086. You don't need to say this separately. You just need to use that in the sentence. Provides an interpretation that references an increase of grams in mass for each 1 millimeter increase in length. Milliliter. I'm funny. Indicates that the slope represents a change in the prediction using such language as predicted, estimated, expected, or average. You get a P if you had 2 of the 3 of those, and an I if you did not have that. Okay, this is interesting. I want to point something out here. In the notes, it says the value of the slope 6.086 may be rounded to 6.09 or 6.1, but not to 6 to satisfy the numerical requirement of component 1. It wouldn't even occur to me to round that. because they gave me the number, but just letting you know that this is the only time I've ever really seen them care about rounding. And then it says if it contains 6.086 in the interpretation, it satisfies component one. That's where I meant you didn't have to specifically say the slope is 6.086 and then put the sentence. Okay. Here's mine. I did it because I'm a nerd pants. Slope is this. For every increase in 1 millimeter of length, we predict an increase of 6.086 grams of mass in bullfrogs. Okay. Part C. I'm assuming that part C is one that you're going to have to review a few times before the AP test. This is not one that I don't feel like it rolls off the tongue very easily. I think the slope one does. I don't think this one does. Okay. You get an E if you have the correct interpretation in context. You get a P if you have a generic interpretation with no context, or a reasonable but incorrect. I don't even know what that would be. Okay, but let me show you what I have. This is what I taught you to do in class. 81.9% of the variability in mass can be explained by a linear relationship. Notice this is whited out. I had the word association there. Then I read later that association and relationship can be interchanged. That does not matter with length of bullfrogs in millimeters. Yes.
Can I read my sentence?
Yes.
I wasn't sure. I just remember it. All right. So I said, R squared equals 0.819 is the square root of the residual from the first explained for linearity to these regression line. There's an 81.9% correlation between length and mass.
Okay, so here are some other correct examples. I think yours is close to this one, but not quite there. I think so. And honestly, I was kind of expecting that for this one, because this is not one of those that we do really pass that chapter a lot. And so I was expecting that this one would be rough to remember. Anyone else want to ask about their sentence or anything? I'm wondering if most of you just flipped back to the chapter and looked it up. Okay, okay. All right, last bit for number one. You need to have two components for an E. You need to say the correct bullfrog had a length somewhere between 160 and 165, just whatever you thought, and a mass between 350 and 375. I put length is about 162, mass is about 355. And then you have to say that it overestimates. The correct answer is that it overestimates. And you have to say something about a correct justification. Examples of that is the point is below the line, or you could say the line is above the point. If you said something really, really fancy, I'm sorry. All you had to say was that the line was above the point or the point is below the line. Did anyone say anything fancy, like super fancy, and they want me to see if their fanciness counts? Oh, you could also say that the residual was negative. So that would be overestimating. Anyone say that? That's kind of smart though, now that you think about it. This is what I said. Least squares regression line overestimates the bullfrog in part D1. The prediction line is above the observed mass and length coordinate of this bullfrog. Okay, take a second to tally up your number one, please. All right. Flip to number two when you're ready. Two A. For an E, you need three components. Identifies the treatments as the new drug and the placebo. Identifies the experimental units as the 72 people. You can say subjects or participants or twins. You don't need to say 72 and you don't need to say 36 pairs. You just need to identify them as the people. Trust me, I read this out. It says the response could refer to participants, subjects, twins, or members of the pairs of twins without explicitly mentioning the number 72 or 36. And then response variable as the improvement in acne severity.
I didn't like improvement, but I did the acne severity on a scale of 0 to 100, but that's still qualified.
Hold on. Okay. I'll read this. It says, satisfy component 3, the response must include the context of acne and improvement. Acne, but it does not need to include a reference to the scale, dermatologist, 2-week time periods, or treatments. Reasonable synonyms for improvement can be used, such as reduction or change, or by including the verbal descriptions of the scale, no improvement to complete cure. However, a description of the binary outcome, whether or not the acne improves, does not satisfy component 3. I don't think that works because you didn't, yeah. But this is why we're doing this. This is why we're doing this, little tiny stuff like that. Okay. B. I'm expecting B to be challenging, by the way. So if you did not do that well on B, I'm not shocked. When I was doing this one, I was thinking to myself, this is hard. Okay. So you have to say a statistical advantage of a matched pairs design. You might not even know what that is. And you have to say something about the ability to distinguish between the, so making something easier to distinguish the effects. Easier, I said easier, I think, to just, so ability to distinguish between the effects. And you need to use a word something like that implies that it's better. So easier, clearer, or greater. And you need to include context, which is like improvement or acne or twins. I know this is rough. Okay. If you only have 2 of those, 3 plus the statistical advantage, you don't probably might be sitting there in your seat right now, still not knowing what the statistical advantage is. Okay, but anyway, let me show you what I put, which I think is the simplest answer. Using matched pairs design with identical twins will allow researchers to compare 2 people who have similar acne severity. So the focus needs to be on this sentence right here. This is the key. To the whole thing. Each twin in the experiment has a severity of acne similar to that of the other twin. That is the focus. So using matched pairs with identical twins will allow researchers to compare 2 people who have similar acne severity, and it will then be easier to determine if the new drug will cause higher improvement in acne severity scores versus the placebo. Yes.
For the greater part, if I said that randomized was a less predictive / accurate outcome, would that also count for that?
Don't know. Let's see. Okay, hold on. To be considered an advantage, the advantage described must be true for matchers. Okay. For example, saying that random assignment allows us to conclude cause and effect. No. Similar. No. No. Okay, that's not what you were saying. I'm just trying to find what you were saying.
It's for like the part that says you have to use the word greater, easier, or better.
Okay. Advantages of a match pairs design that satisfies makes it easier to determine, gives a better estimate, reduces variability in the estimate. Okay. Makes the difference between the new drug and more easily distinguishable, gives a clearer picture. I felt like that was hard. That whole thing. Not the backside. I like the backside part, but this I felt was challenging. Yes, Megan.
Go back to B where it showed that it doesn't have.
Yes. Okay. So a statistical advantage. Mine was allowing researchers to compare two people who have similar acne severity. You need to say something about the ability to distinguish between the effects. So like distinguish between the new drug and the placebo. You need to say something about match pairs being better because they will make it easier or clearer or greater chance. And then you need to say something about context. If you said a statistical advantage and only one or two of these, that's a P, everything else is an I. But I felt like we can come back around on the backside here. Okay. Okay. So, all right. You need to do 4 things for an E for C here. You need to randomly assign the 2 treatments within pairs of twins, meaning sometimes twin A or twin 1 gets the new drug, sometimes twin B gets the new drug, and the other one gets a placebo. Okay. You also need to use a random process. They use flipping a coin, using a random number generator, and cards. I actually used a hat method in mine, but some kind of random process. You need to describe how to assign one twin to the drug and the other twin to the placebo. And you need to say that it will be completed for each pair of twins. Hey, it's good. It's good. Okay. This is what I put. Label each set of twins with twin 1 or twin 2. The labeling is extremely important. Place 2 slips of paper in a hat labeled 1 and 2. Draw a slip and assign the chosen twin in that pair to the new drug and the other twin to the placebo. This is also, if you're going to use slips of paper, extremely important. Replace the slip and mix before drawing again and repeat for all 36 sets of twins. That's just what came to me. They liked flipping a coin when the scoring guidelines. Which now after I read the scoring guidelines, I was like, oh, that's probably simpler, but that's okay. All right, get your scores for number 2 situated, tallied. Okay. Hold on. Dropped my highlighter because I'm a champion. Okay. All right, here we go. Number 3A has 3 components, indicates the use of a normal distribution, and identifies the mean as 0.6 and the standard deviation as 0.04. I met this requirement by writing normal CDF and then labeling my mean and standard deviation inside my normal CDF. Yes,
Would that be count? Writing SD individual.
I think so. They have a bunch of I mean, this is what this is like kind of their minimum. But hold on. It also says specifies the correct event boundary value and direction. And I did not label inside my normal CDF. I instead chose to put this statement. So this statement covers me for the boundary value and direction. If you did not write this, then you needed to write lower and upper here. But this is why we're doing it. That's why we're doing this. Okay. And then correct probability of 0.0062. So meaning that there, if you did this stuff wrong, your answer should go with this stuff. You're not going to mark you wrong for the number if your setup was incorrect, which is nice about College Board. Yes.
So I drew like a little normal thing and then I labeled it because standard deviation is like with most things back and forth.
Yep, totally. They actually, if you hold on 1 second, it says that you could provide a displaying a graph of normal density function showing the mean and standard deviation covers. Yeah.
Wait, no, I did do that. Never mind. I did draw a graph.
Drawing a graph, they love that. Just really quick, I want to talk about the P in this. If you only got 2 of the 3 things, or you didn't get component 1 or 2, but you did the correct Z-score and correct probability, you could get a P. So what they're saying is, for those of you people that are math people and not stats people, which I, for most of my life, was definitely a math person and not a stats person, and I just wrote the numbers, they're saying you can get a P. Okay. All right, B. Oh goodness, you need 4 components. Okay. I also think that this was hard. So if you think that this, if you found this hard, I was not surprised. Defines the random variable as the number of unfilled bottles in a box of 10. Okay. Indicates that it is binomial with n is 10 and p equals 0.0062, or your incorrect probability from the previous one. Okay, here's what I did. Pausing real quick, I said X equals the number of underfilled bottles in a box of 10 bottles, binomial with N equals 10 and P equals 0.0062. If you didn't get this, I gotta tell you, I'm not shocked. This is one of those things that I feel like you see this and you think to yourself, oh crap, I need to read the whole binomial and geometric section of my notes. Like that I feel is totally normal. Okay. Provides supporting work for the calculation of the probability in part B2 that identifies the event of interest. Okay, so what they mean there is some kind of work for the binomial. Now, I did not need to label N and P because I labeled N and P up here, and there is my boundary value. And then gets the correct probability of 0.0017. So you need to have all four of those things, this, work, and answer to get an E. Yes. I think that's okay. Because it says, did you use N, did you say N was 10 somewhere in the problem? Did you say N was 10 and the probability was 0.0062? Oh, that's fine. Trials 10 is good. So I think saying bottles underfilled would get you number 1. And I think saying trials 10 would get you this if you have that somewhere written too. Yes.
So I think that's the first, I think it's select box without counting if I didn't say like I was trying to for someone. But for part one. If we-
I think this is, well,
The second question though, is if my calculations, I like use the 10 and the 9, would that demonstrate N or would I have to specifically work?
I think you're here.
We feel like I manually did binomial.
I was not back on your first question still. Referring to a box does not satisfy the requirement for parameter N equals 10.
Right, but talking about.
I know, but the calculation part, the second question you had. So, you manually did that. You did this? No. You did binom PDF and added 0 and 1?
No, I binomial formula.
This.
Yeah.
I think this is totally fine.
Okay.
Unexpected, but totally fine. And you can also have 10 combination 1 here and 10 combination 0 here. It does not have to look like the stats notation. They don't care. It's cool that you did that. Unexpected. Okay. See. Okay, you can get an E 2 different ways. You can compare probabilities or compare z-scores. I highly doubt anyone in this room compared z-scores. If you did, I'm gonna be just as surprised as I was by Gabe using the brute force binomial formula, but you know, it's good. Okay. So you need to correctly calculate the probability of underfilling a bottle for as 0.023 for the adjusted programming of the filling machine. And then you need to say a correct conclusion about which programming, which is the original, should be recommended. So, and why? I said, here's my normal CDF boundary labeled 0.0228. The company should use the original programming. The probability of getting an underfilled bottle is greater for the new programming, so it would result in more rejected crates of bottles. And you could flip this, of course, and say the probability of getting underfilled bottle is less for the original programming, so it would result in less rejected crates of bottles or something like that. Yes.
I did something that I expected really wrong. I said that there were more standard like deviations away.
That's not necessarily wrong. Hold on. Hold on. Did you get the 0.023? Did you get the probability?
Oh, from the,
Yeah.
from the actual, like,
From the new programming? Did you get this number?
I don't think I did.
Okay, so I think the only thing they're going to accept is comparing probabilities or comparing z-scores. I don't think they will accept comparing standard deviations. Wait, pause. Did you? Z-score is how many standard deviations from the mean it is.
Yeah.
So did you find z-score was 2.5 and z-score was, I mean, negative 2.5 and negative 2.
I think I would have gotten it wrong anyway. I'm just more talking about the.
Okay, so what you could have done is you could have found the actual amount of standard deviations away that this is and the actual amount of standard deviations this is, and then compared, this would be farther away than this one. But I think you needed the calculation of the 2.5 and 2. So you're not wrong, you just needed math. What? We actually needed math in a stats problem? Weird. Weird. Oh wait, number 4 is.
These are gonna be my lifesaver.
I know.
The AP exam.
I heard what you guys the other day in class when you flipped to number 4 and you're like, a confidence interval.
I can do confidence intervals or tests.
Yeah, but it's the semester 1 stuff that we don't remember. Okay, anyway, moving on. Number 4. A. Identifies the appropriate procedure as one sample Z interval by name or formula or by calculations of the correct interval. And so you can actually, apparently now they've made it so you don't need to say this in the plan anymore. You just need to get the correct answer. But if you get the wrong answer, you're still covered if you do say it. So I would just say it, unless you're going to be that confident. And then you need to say that the parameter of interest is the population proportion. Okay, so for us, this would be the state and the first line of the plan. So 95% confidence interval for P equals the true proportion of all teenagers in the US, blah, blah, blah. This covers me for the second part, and then saying Z interval for P covers me for the first part. So this and this. What? Hold on. If you got only one of the two of those things, you got a P, otherwise that's an I. What? What? You sure?
Yeah.
Okay. Section 2. You need to state that there is a random sample. You need to state that 920 is less than 10% of all teenagers in the US. you need to calculate n times p, and n times 1 minus p is 542.8 and 377.2. These can be rounded, but I don't suggest it. And then the actual answer is the fourth step. So the correct interval. The correct interval is 0.558 to 0.622. So you need this, this, and then the actual answer to the interval is all section 2. How many people had to like stop for a minute and remember n times p and n times 1 minus p? Yeah. Okay. Wait, there's no central limit theorem here. We've done this too long. Too many T procedures. Okay. Section 3 indicates 95% confidence and says something like we are 95% confident, and provides interval endpoint values consistent with calculations in section 2. So they just want these numbers to match whatever you had. You don't get double marked wrong, which is nice. And then conveys inference about population proportion in context. So true proportion of US teenagers. This is section 3. I don't think there's a section 4.
Oh.
It's
It's FRD,
it's,
that's why I was-
B. It's B, but section 4 is part B.
Oh, it's on the back. It's on the back. It's on the back. Sorry. Can't see 2 feet in front of me. Okay, now section 4 is you need to say there is convincing evidence. And then you have to say whether or not 0.5 is contained in the interval. 0.5 is not in our interval, so we do have convincing evidence. Did you guys get 4s? Yay. I know.
I just have to remember that because the margin of error. I just remember that for the Q.
Oh, yeah.
I forgot the calculations for P and I had to look at the formula sheet.
But you can look at, like, if you know where to go on the formula sheet, that's what I want.
Is that the formula sheet we get?
Exactly the same.
Oh, do we get to bring that one in?
No. It's like the first page in the book and you can rip it out.
Oh.
Yeah, I think you can. You used to be able to anyway. I want to ask if anyone did this. Did anyone do inverse norm? And then it came out to 1.96 and then you went, duh, of course it's 1.96. Like you had that memorized so hard that for a while.
But just to be safe.
Yeah.
I did inverse.
I knew it wasn't, but then for college board, I'm like, I'm gonna do inverse norm to make them happy because they are fickle.
They are fickle. They are fickle. Okay. Number 5.
That's what college board is.
I did not like the middle part of number 5, by the way.
And
I like the end part.
I didn't do the end part.
Okay, you're gonna feel really silly when I show you the end
Yeah,
part.
no, no.
Okay, all right.
Didn't have time.
So the first part should be easy. You need to say that the median is 7 for dark chocolate, and you can say the median is anywhere between -2 and 2 for the white chocolate. I put 0.
Yeah.
The computed medians are compared correctly, so I guess that they want you to say 7 is greater than 0. And then you need to have some kind of context. Yes.
Why would it be -1.2? Because there's no, it's because that's. That's the one where you add and divide by 2, basically, but because it says it's -0. I can't, I missed this.
Did you miss this outlier guy?
Yeah.
Eh?
I missed the -1.
Heh.
Yeah.
Okay.
Is it okay
Yeah.
if I write the equation of how I did 7 minus 0 and then put that there's a difference of sort of between the dark chocolate and white chocolate?
Do you have to say something about
I
Um,
said, yeah, so the dark chocolate has a higher.
Oh, yeah, then you're good,
reduction.
then you're good, then you're good. Okay, the median is greater than the median 7 versus 0. I don't
Didn't
know.
mention
They just wanted you
medians.
to be able to count in on your fingies. Now, question, you can tell me this or you can not tell me this. Did anyone sit there and spend the time putting all of these values into L1 and do one variable stats and have it give you the medians?
The only reason
No,
I
I
did
just
is-
counted.
Okay, you should just count. Now, don't get me wrong. Like, if I had extra time on the AP test, I might do that. But
I was too lazy to put it in for everyone.
no, the cover up fingy method is totally legit. Okay. If you got 2 of the 3 components and the reported values of the medians are something reasonable, you could get a P. Or if you get components 2 and 3, wait. Oh, one of the components 2 or 3 and the medians are reasonable, you can get a P. So you basically do nothing on a 7th grade problem and get a P. Awesome. Awesome.
So for that, if I don't compare the medians, I just take them out to do.
Correct. Okay, now this is the part where I think our score might tank on this problem. Okay, you need at least 2 of the following 3 things. You need to say that researchers failed to consider the variability. So did not have standard deviation, something like that, did not consider variability. Or you could say that different random assignment could produce different sample means. So you had to say something like they needed standard deviations or random assignment would produce different sample means. You also have to say, well, you need 2 of the 3, but you have to say that 5.66 could have occurred by chance. And that you need to say that an inference procedure, or you could say that an inference procedure was needed, meaning a hypothesis test or a confidence interval. I'll be really interested to see if you guys have questions on this one, but I'm going to read you mine. Yes, honey.
What are the any of the unexpected variables with confounding variables?
Nope. Doesn't say anything about confounding variables at all. Like even down here, it says no conclusion can be made. No, nothing. There's nothing about that, which I'm surprised about. I find that weird. Yes, honey.
If I said that like an outlier might impact results if they're just using means instead of medians, would that work?
It doesn't say anything about that.
But like,
It is true, but I think that even still, you can't do an inference procedure without standard deviation. Okay, this is what I put. Again, I'm not shocked if we didn't do well on this part. When I was doing this on the couch, I was like, this one's gonna be rough. A hypothesis test for difference of 2 means would require comparing both sample means and sample standard deviations. Another random assignment of treatments of the different chocolates might produce different sample means that have a smaller difference than these just by chance. I didn't really love that, so I'm with you if you didn't love that either.
so is this basically asking for conditions of a hypothesis test?
It felt like that's one way you could go. Do you guys want to read their answer too? Their answer is like, okay, the researcher's conclusion may not necessarily be true because looking at the difference in sample means alone does not consider the variability in the sampling distribution of the differences in sample means. Another random assignment of subjects to dark and white chocolate may result in sample mean reduction in blood pressure for subjects assigned to dark chocolate that is smaller than the mean reduction for subjects assigned to, my God. The variability in the sampling distribution of potential differences must be considered in making a conclusion about convincing statistical evidence. Further, An inference procedure can assess the likelihood that the observed difference in sample means occurred by random chance if the population means are equal. I would never write that. I gotta be honest with you. I feel like I'm a pretty smart lady and that's not something I would just naturally like have come out of my hand onto a paper. But you know. Okay, but I think I might have recovered myself on the next one. Okay. 4 components, you need to calculate the p-value is 0.025. I did that by doing a circle. Nice. Okay, what you do is you take the answer from this. So difference of 5.66 down here. And the p-value would be wherever the difference would be greater than 5.66, which is those 3 dots. And the reason I said greater is that because it says reduction in blood pressure. So it says greater reduction in blood pressure. So that means a greater difference. So I stole the difference from the previous problem. And those 3 dots were the only ones that were above 5.66. And then I just wrote the conclusion sentence that we always write. So you have to calculate the p-value. You have to provide supporting work from the simulation. That was my circle, I believe. Correct conclusion of whether there's convincing evidence. There is convincing evidence in this one. And then directly comparing the calculated p-value to 0.05. So here's mine. Since our p-value is less than 0.05, we reject the hope. Again, very important here. Let's say you're taking the AP test. It's going to flash, it's fine. And you don't have any idea what, first of all, if you see a dot plot like that, it's going to ask you to count a number of dots out of something. Okay, if you don't know what to do and you don't know what dots it's talking about, first of all, it's going to be one of the or other of the tails. I can tell you that. Just circle a set of dots, calculate a fraction, or come up with some kind of reasonable number for p-value and make sure you write this. Because you can still get a p, even if you don't know how to get the p-value, but you come up with some phantom p-value and write the sentence. If I've taught you nothing else, you forget the calculation step, don't stop. Because look at this right here. You get a P if you satisfy only 2 of the 4 components. That would be stating whether or not there is convincing evidence based on your number and directly comparing the p-value to 0.05. I don't know what he wants. Correctly comparing the p-value to 0.05. You see what I'm saying there? You can skip the entire calculation section and still get a P on this problem. Am I saying what, is it clear? Are you picking up what I'm laying down? Yes? Okay, all right, last one. Number 6. And remember what I said about number 6. Number 6 is out of the scope of the curriculum, which means that they're going to see how you work with something that you don't know, which is awesome. Now, everyone in the class should know how to do A. It's been a hot minute, I'll give you that, but we should know how to do it. So you need to provide correct numerical values for the relative frequencies. Here they are. You could round them differently, but here they are. And then identifies the clinic that is more successful in treating allergy sufferers and includes a justification. So it's supposed to be clinic A is more successful because it has a higher percentage of successful treatment. So clinic A is more successful because this number is bigger than that number. It wasn't bad once you got past the what the heck the mosaic plot was saying. If you could read the mosaic,
It took me a while for the mosaic plot, and I was like, oh.
it's kind of cool.
Yeah, no, it's really cool. I really like that.
But then again, I was like, we don't do this. But expect, you have to expect the unexpected in number 6. So don't be shocked if don't be like, Mrs. Talbot, you jerk, you didn't go over this. Because I won't have. I don't remember us ever doing a mosaic plot, did we? I don't even think I've ever seen one before in my life before doing this.
Cool way of showing it, but I liked it.
Oh, I liked it too. And especially if you're a visual person, like it was right up a visual person's alley, but I didn't picture myself breaking out the ruler and graph paper and proportional amount of boxes for each, Okay, B. B is my favorite because it gave you an entire page to write one sentence.
That was the funniest thing.
I know. Okay, so you need to say no. And then you need to either say that it's an observational study, it's not a randomized experiment, or identify a plausible confounding variable. You could literally say no, it's an observational study, and get an E for this question.
And why? Observational studies are, I thought that's one you can apply to everyone.
But it is. That's not what this is asking, though. This is asking about cause and effect.
Oh, is it?
Yeah, see the word causes right there after A2.
Oh, darn it.
Okay, I wrote, no, there's random sampling, which makes this an observational study, and you cannot determine cause and effect. That was my really great use of this entire piece of paper there. Okay. Not never. It's never if there wasn't also. So some studies are actually experiments and observational studies at the same time. You can have random sample of people and then randomly assign them to treatments. In that case, you could do both generalizing to the population and cause and effect. Yeah, assigned treatments. Now, how often does that happen? How often are you going to go up to some rando and say, by the way, can I give you some new drug or a placebo? Like that's just, extremely unlikely. I just didn't want to say it was impossible.
So, if I said yes, and I gave my conditions, like random 10% match counts, but I guess.
Mm. I think that's a no.
So, the response that is going to the scale indicated you can't go for
That's saying that if you
it.
say, if you just write, yeah. So it's saying if you just write, this is an observational study, but don't make a decision either way, then that's a P. So you would have gotten more with being non-committal, which is weird, but whatever. Okay. This is where I started to, it was interesting. Okay, 4 components. You need to say that clinic A and B are both more successful in treating mild allergies. And you need to provide a justification based on proportions or percentages. So I said mild allergies are more successful. Clinic A was successful with 75. I did everything. I did the fraction and the decimal and the percent. I don't even know why. I did not need to do all that. I could have just said 75% of mild allergy sufferers, but only 29% of severe allergy sufferers. I think I was just writing out my thoughts there. Like, I don't know. Okay. And then for Clinic B, I said mild allergies are more successful. Clinic B was successful with 11 out of 12, 92% of mild allergy sufferers, but only 43% of severe allergy sufferers. Okay, so you needed to say mild was better in both and give some kind of correct justification for those. So that was the first two. Okay, then flip paper over here. You need to say Clinic A is more likely to treat mild allergy sufferers, and Clinic B is more likely to treat severe allergy sufferers. And then correct justification based on frequencies or proportions or percentages or all three if your teacher's a weirdo. So mild allergy sufferers are more common. Clinic A treated 75% of patients with mild allergies and 25% of patients with severe allergies. Clinic B, severe allergy sufferers are more common. Clinic B treated 56 out of 68, 82% of patients with severe allergies and 18% of patients with mild allergies. So mild, severe, percent. If you got 2 or 3 of the 4 components, you got a P, otherwise it's an I. Oh, this is fun. If you know about mosaic plots, you could have made a correct reference comparing the ratio of shaded area to open area instead of proportion amounts. That wouldn't even occur to me, but if you did that, that was cool. Okay, last thing, right? Okay, 2 components for an E. Okay, you need to say something about the proportion of successfully treated mild allergy sufferers is greater than the proportion of successfully treated severe allergy sufferers with stuff. I said for mild allergy sufferers, Clinic A is better. Clinic A treats a larger percentage of mild allergy sufferers than Clinic B, and it is also more successful in treating mild allergies. Gosh, this is hard to grade. Okay, so let's just focus on component 1. You could say successfully treated mild allergy sufferers is greater than the successfully treated severe allergy sufferers. Or you could say the overall proportion of successfully treated mild allergy sufferers is larger than the overall proportion of successfully treated severe allergy sufferers. Did I do that?
You give the numbers, just the word.
It doesn't say anything about justification. It just says, it doesn't say you have to justify it. I would if I were you, but okay. And then for component 2, there's actually 3 options. The allergy sufferers, I don't even know if I got this right. The allergy sufferers treated by Clinic A is a much greater proportion of mild cases than the allergy. Oh, no, I did. So you could say Clinic A has more mild than Clinic B, or you could say Clinic B has more severe than Clinic A. Or you could say this is the same thing as those. I don't know. Okay, so I said, my second part was Clinic B does treat more severe allergy sufferers, but is also more successful at treating mild allergies when compared to severe allergy sufferers. What did I get on this problem? I don't even know. Like, I know this first part. I find this challenging to grade. I'm really glad I'm not in the bottom of a hotel for a week in 2022 grading this during my summer, because, or at least that they didn't give me question 6. I think of the other ones I could have probably lived with, but this is. Did anyone want to ask about theirs? Yes.
I don't think I got this right, but anyway, I can identify clinic A as more severe treatment overall, with a higher overall success rate.
Okay.
They, with that, I think, but so with that, I think in treating both mild and severe allergies. But I don't think that's right.
I think that's P. I think it's one of the two. I do think that's a P.